Apple juice is a fruit juice made by the maceration and pressing of an apple. Apple trees are cultivated worldwide and are the most widely grown species in the genus Malus. The tree originated in Central Asia, where its wild ancestor, Malus sieversii, is still found today. Apples have been grown for thousands of years in Asia and Europe and were brought to North America by European colonists. Apples have religious and mythological significance in many cultures, including Norse, Greek, and European Christian traditions. Apples grown from seed tend to be very different from those of their parents, and the resultant fruit frequently lacks desired characteristics. Generally, apple cultivars are propagated by clonal grafting onto rootstocks. Apple trees grown without rootstocks tend to be larger and much slower to fruit after planting. Rootstocks are used to control the speed of growth and the size of the resulting tree, allowing for easier harvesting. There are more than 7,500 known cultivars of apples. Different cultivars are bred for various tastes and uses, including cooking, eating raw, and cider production. Trees and fruit are prone to a number of fungal, bacterial, and pest problems, which can be controlled by a number of organic and non-organic means. The resulting expelled juice may be further treated by enzymatic and centrifugal clarification to remove the starch and pectin, which holds fine particulate in suspension, and then pasteurized for packaging in glass, metal, or aseptic processing system containers, or further treated by dehydration processes to a concentrate. Due to the complex and costly equipment required to extract and clarify juice from apples in large volumes, apple juice is normally produced commercially. In the United States, unfiltered fresh apple juice is made by smaller operations in areas of high apple production, in the form of unclarified apple cider. Apple juice is one of the most common fruit juices globally, with world production led by China, Poland, the United States, and Germany. The apple is a deciduous tree, generally standing 2 to 4.5 meters, 6 to 15 feet tall in cultivation, and up to 9 meters, 30 feet in the wild. When cultivated, the size, shape, and branch density are determined by rootstock selection and trimming method. The leaves are alternately arranged in dark green-colored simple ovals with serrated margins and slightly downy undersides. Blossoms are produced in spring simultaneously with the budding of the leaves, and are produced on spurs and some long shots. The 3 to 4 centimeters, 1 to 1 plus 1 D2 in, flowers are white with a pink tinge that gradually fades, 5-petaled, with an inflorescence consisting of a cyme with 4-6 flowers. The central flower of the inflorescence is called the king bloom. It opens first and can develop a larger fruit. When the fruit is a pome that matures in late summer or autumn, and cultivars exist in a wide range of sizes. Commercial growers aim to produce an apple that is 7 to 8.5 centimeters, 2 plus 3 D4 to 3 plus 1 D4 in diameter, due to market preference. Some consumers, especially those in Japan, prefer a larger apple, while apples below 5.5 centimeters, 2 plus 1 D4 in, are generally used for making juice, and have little fresh market value. The skin of ripe apples is generally red, yellow, green, pink, or russeted, though many bi- or tricolored cultivars may be found. The skin may also be wholly or partly russeted, i.e. rough and brown. The skin is covered in a protective layer of epicuticular wax. The exocarp, flesh, is generally pale yellowish-white, though pink, yellow or green exocarps also occur. Juice is prepared by mechanically squeezing or macerating, sometimes referred to as cold-pressed fruit or vegetable flesh, without the application of heat or solvents. For example, orange juice is the liquid extract of the fruit of the orange tree, and tomato juice is the liquid that results from pressing the fruit of the tomato plant. Juice may be prepared in the home from fresh fruit and vegetables, using a variety of hand or electric juicers. Many commercial juices are filtered to remove fiber or pulp, but high-pulp fresh orange juice is a popular beverage. Additives are put in some juices, such as sugar and artificial flavors, in some fruit juice-based beverages, savory seasonings, for example in clamato or Caesar tomato juice drinks. Common methods for the preservation and processing of fruit juices include canning, pasteurization, concentrating, freezing, evaporation, and spray drying. Although processing methods vary between juices, the general processing method of juices includes washing and sorting food sources, juice extraction, straining, filtration and clarification, blending, pasteurization, filling, sealing, and sterilization, cooling, labeling, and packing. After the fruits are picked and washed, the juice is extracted by one of two automated methods. In the first method, two metal cups with sharp metal tubes on the bottom cup come together, removing the peel, and forcing the flesh of the fruit through the metal tube. The juice of the fruit then escapes through small holes in the tube. The peels can then be used further, and are washed to remove oils, which are reclaimed later for usage. The second method requires the fruits to be cut in half before being subjected to reamers, which extract the juice. After the juice is filtered, it may be concentrated in evaporators, which reduce the size of the juice by a factor of 5, making it easier to transport and increasing its expiration date. Juices are concentrated by heating under a vacuum to remove water, and then cooling to around 13 degrees Celsius. About 2/3 of the water in a juice is removed. The The juice is then later reconstituted, in which the concentrate is mixed with water and other factors to return any lost flavor from the concentrating process. Juices can also be sold in a concentrated state, in which the consumer adds water to the concentrated juices preparation. Juices are then pasteurized and filled into containers, often while still hot. If the juice is poured into a container while hot, it is cooled as quickly as possible. Packages that cannot stand heat require sterile conditions for filling. Chemicals such as hydrogen peroxide can be used to sterilize containers. Plants can make anywhere from 1 to 20 tons a day. High-intensity pulsed electric fields are being used as an alternative to heat pasteurization in fruit juices. Heat treatments sometimes fail to make a quality microbiological stable product. However, it was found that processing with high-intensity pulsed electric fields can be applied to fruit juices to provide a shelf-stable and safe product. In addition, it was found that pulsed electric fields provide a fresh-like and high nutrition value product. Pulsed electric field processing is a type of non-thermal method for food preservation. Pulsed electric fields use short pulses of electricity to inactivate microbes. In addition, the use of PEF results in minimal detrimental effects on the quality of the food. Pulsed electric fields kill microorganisms and provide better maintenance of the original color, flavor, and nutritional value of the food, as compared to heat treatments. This method of preservation works by placing 2 electrodes between liquid juices, and then applying high-voltage pulses for microseconds to milliseconds. The high-voltage pulses are of intensity in the range of 10 to 80 kV/centimeter. The processing time of the juice is calculated by multiplying the number of pulses by the effective pulse duration. The high voltage of the pulses produces an electric field that results in microbial inactivation that may be present in the juice. The PEF temperatures are below that of the temperatures used in thermal processing. After the high voltage treatment, the juice is aseptically packaged and refrigerated. Juice is also able to transfer electricity due to the presence of several ions from the processing. When the electric field is applied to the juice, electric currents are then able to flow into the liquid juice and transferred around due to the charged molecules in the juice. Therefore, pulsed electric fields are able to inactivate microorganisms, extend shelf life, and reduce enzymatic activity of the juice, while maintaining similar quality as the original fresh-pressed juice. Fresh apple juice requires refrigeration. Sealed bottles of canned apple juice can be stored in a dark, cool place, such as a pantry or cupboard, to delay the degradation of the product. The appearance, texture, or taste of the juice might change over time. Once the juice package is opened, or if it was not sealed and shipped without needing refrigeration by the manufacturer, it must be resealed tightly and refrigerated to avoid contamination from microorganisms such as bacteria. The ideal storage temperature for apple juice is between 0 and 4 degrees centigrade. Depending on the original package of the apple juice, it could help to transfer the contents to a new container. For example, if the original package was a Tetra Pak, which does not permit contact of the product with light, then it is safe to refrigerate as is. However, if the product was initially in a clear glass container, transferring the apple juice into an opaque container would help extend the shelf life of the juice. This may include a thermos or plastic bottle.